Many medieval European texts on the natural sciences center on the work of a single scholar, Geber. This was the Latinized name of Jabir ibn Hayyan, a figure whose work influenced both Eastern and Western scientific thought for centuries. But at the time of his birth, around 721 CE, the world was a different place. Chemistry, as a formal and rigorous scientific discipline, had not yet emerged. This map shows the Khorasan region, a vital crossroads of the 8th century Islamic Empire. Merchants, scholars, and craftsmen moved through the city of Tus constantly, turning the region into a hub where ideas traveled as frequently as physical goods. This era of cultural exchange was also an era of deep political instability. The early Islamic Golden Age was defined by violent struggles for power that often reached into the lives of private citizens. This raises a difficult question. How does a child born into such a volatile environment, centuries before the first modern laboratories, develop the specific expertise required to invent a new branch of science? The foundation of modern chemistry wasn't built in a quiet library. It was forged in a period of history that prioritized practical results and physical survival over abstract theories. Jaber's introduction to the physical world began in his father's shop. Hayyan al-Azdi worked as an apothecary, a profession dedicated to the creation of medicines. Being an apothecary was a tactile trade. It meant handling raw herbs, grinding minerals, and mixing compounds to see how they reacted. This work was purely practical. Jaber learned what these mixtures did to the human body, but he lacked any framework to explain the chemical mechanisms occurring beneath the surface. While this childhood in the shop offered no formal scientific theory, it provided something irreplaceable, a deep, hands-on familiarity with the behavior of matter. This childhood stability ended when Hayyan al-Azdi joined the Abbasid movement, a political faction opposing the ruling Umayyad authorities. The state eventually arrested and executed Hayyan, leaving his family without a protector. Jaber's family fled from Khorasan to the Arabian Peninsula. They left their comfortable trade life behind, entering a period of poverty and exile. This hardship redirected Jaber's trajectory. In a world where his family's trade and safety had been stripped away, education became the only path left to rebuild his life and improve his circumstances. Jaber pursued a diverse curriculum, studying the Quran, mathematics, and philosophy. His study of the Arabic language was particularly influential. Its strict grammatical rules and linguistic structures trained his mind to look for predictable systems within the natural world. Historical traditions also link him to the scholar Ja'far al-Sadiq. Under this tutelage, Jaber was introduced to the formal rules of logic and the importance of structured reasoning. This theoretical training provided a connective layer. It gave Jaber the formal tools he needed to look back at the practical apothecary work of his youth through a lens of scientific inquiry. He began applying the classification systems of his logic studies to the minerals he had once ground in his father's mortar. This shift moved him past the apothecary's rote recipes and toward a new demand. He wanted to find a verifiable system that could prove why certain materials interacted the way they did. Jaber inhabited the space between two different worlds, the manual labor of the workshop and the abstract debates of the academy. His breakthrough was to merge these two spheres. He subjected the dangerous physical handling of minerals to the rigorous mathematical and logical frameworks he learned in exile. This combination, testing the physical world against a theoretical hypothesis, is the very definition of experimental chemistry. The result was the creation of early laboratories, equipped with furnaces and scales designed to measure the transformation of matter. These tools and methods would define science for the next 1,000 years. Experimental chemistry was not born of privilege. It grew from the intersection of personal tragedy, the practical skills of a trade, and a relentlessly diverse education.